Yeah, today's class we discuss about this using the choppers, using choppers, how we control the DC motors. That topic we discuss today. Uh, Before that, we'll briefly discuss what is a chopper, what it does. Okay. So and some more properties of the choppers. Okay, whichever is necessary, we'll discuss those things today. Before that, uh, we simply now what is a motor? There is a motor is there. And the motor is there. This is the motor. This is the motor. And there is a load is there. Mechanical load. This is the mechanical load. Now both are coupled. See, both are coupled like this. So what a motor does now? Motor will try to it does some mechanical work. Motor does some mechanical work. So, for example, you take rotatory motion, then the motor will rotate the load. Some load is there here, so the motor will develop a torque E, whereas every load has some torque EL. Okay, so now both the torques are in the opposite direction. So if it is in this direction, then the low torque will be in this direction. That is opposite to that. Okay? So now you see now. So there is a motor is there. So motor will develop some torque. So that you call it as electromagnetic torque. Every load has some torque. So it depends upon what is the type of load. Okay. It depends upon what is the type of load and what does load actually does. Okay. So based upon that, that load has some torque. Okay. Now between these two, okay, between these two, so you need to means you will connect the motor, definitely connect the motor to the load. Okay. Say for example, one example I will take. Washing machine is there. So inside the washing machine you have the motor. So now you give supply to the motor, then motor starts rotating. Okay. Then you see here what will happen initially is that say for example you pour all the cloths, all the material you to which you want to wash, that you put inside the washing machine. Then you just give the supply. When you give the supply, what will happen is that the motor starts accelerating. The motor starts accelerating. So when the motor starts accelerating, now this acceleration will slowly become zero. So acceleration becomes zero in the sense its speed remains constant. So at that time, what you will observe is that you will observe a balance equation between the motor torque and the load torque. So that equation I will write here right now. That equation is T is equal T T and now. So there is another term is there. So in terms of, for example, you take the case of uh, rotatory motion. Then in that case, what we find out is that T is equal to load torque TL plus d by dt of j omega m. J is moment of inertia that you know in case of the rotatory motion, and omega m is this is omega m. It is rotating with some angular speed omega m. So so the electromagnetic torque that is developed by the motor. Now, what you do to the motor now? You generally give motor in electrical supply. You have some electrical supply to the motor, then motor will develop a torque. That torque you call it as electromagnetic torque or just T. Now this motor is coupled to the load. and so it tries to rotate the load, or it tries to work on the load. Then two possibilities are there. See here, there are two possibilities. One possibility that just may have seen, either the motor accelerates, okay. Second option is that motor decelerates, it slows down. This is speeding up, this is slow down. And there is another possibility, that what is that possibility is that motor runs with constant speed. Constant speed. These are the three possibilities for every motor. For any application you connect, for any load you connect to the motor, definitely either it accelerates or decelerates or it runs with constant speed. These are the three possibilities. There is no other possibility. So for example, you take the case of acceleration. Acceleration in the sense, what will happen is that something like that, the speed of the motor rises. If the speed of the motor rises, then what you find out is that this part, this part is there. So we can, I can simplify this part further. T is equal to TL plus J J d omega m by dt plus omega m dj by dt. This differentiation. Now this part is there. This one, omega m dj by dt. This part is there. So this part you consider as zero. Why you generally consider this as zero is that the differentiation of your moment of inertia J, generally you consider this J as constant. So its differentiation is zero. So then what is left here is that T is equal to TL plus J d omega m by dt. Now this omega m, what is d omega m by dt? D omega m by dt is nothing but the angular acceleration. Nothing but the angular acceleration. Okay, so now coming to the case, three cases you have, three cases are there. So when you connect the motor to the load, we'll start like this. We'll just start giving the supply to the motor. So when you start giving supply to the motor, what you generally expect? You will expect acceleration because the speed is now zero. So you start the operation. So when you start the operation, the speed is zero. So then the speed has to increase. So when the speed is increasing, in the sense it is accelerating. So when it is accelerating, what do you find out is that accelerating? What do you find out? This d omega m by dt, when it is accelerating, it is positive. When it is accelerating, d omega m by dt is positive. It's positive because accelerating in the speed is increasing. So when the speed is increasing, d omega m is positive. So if this is positive, then what you find out is that this part is there. So the electromagnetic torque that is to be supplied by the motor has two parts. One is the load torque, the other is, you can call this part, the part which is because of the acceleration, the torque which is because of the acceleration. So you consider this as dynamic torque. Whereas this is a low torque. So the total electromagnetic torque that should be developed by the motor is having two parts. One is the low torque, the other one is the dynamic torque. Now in this case, the dynamic torque is positive because which is acceleration. So it has to supply more torque. It has to develop more torque. One is low torque, the other is dynamic torque. So now what next now? What next is that the speed goes on increase. So the acceleration, so it accelerates. Now at one stage, what do you observe? Either you observe the mixer, or either you observe the grinder, or you observe the washing machine, or even you observe the fan, ceiling fan you observe, or any table fan you observe. What do you find out is that after some time, the speed of the motor remains constant. This you will find out. The speed of the motor remains constant. When the speed of the motor remains constant, then this dynamic torque part is there. So when the speed is constant, when omega is constant, what do you find out? This differentiation becomes zero. So in that case, what do you find out? T is equal to TL. So when the electromagnetic torque is equal to the load torque, the speed of the motor remains constant. This is what you must understand. This is what you understand. Okay. And then coming to the case of second case, that is deceleration. So when you take the case of the deceleration in the sense the speed decreases. So why the speed decreases? Because you are intent to decrease the speed. Say for example, when you intend to decrease the speed, then this dynamic torque part is there. That is, speed is decreasing. So when the speed is decreasing, this d omega by dt. So this part d omega m by dt, it is negative this time. So if it is negative, what do you find out here? T is equal TL plus of course J d omega m by dt. But this time, this time, this part is negative. If it is negative, when it is negative, then it is declarative. So when the speed decreases, you call it as declaration. So this part becomes negative. So when this part negative, in the sense, what will happen if this part negative? Then you send this negative towards the left hand side. Then it will add it up to the motor torque. So the load torque this time is sum of the dynamic torque and the motor torque. So it means it means it will give energy back to the motor. Okay, how comes the energy here? The extra energy is because of this part J d omega m by dt. So you can consider this as the energy stored. You can consider this as energy stored in the motor mechanical parts. Okay, that energy goes back to the motor. So this time motor doesn't need to supply more torque to meet the load torque. It doesn't need to supply more torque because there is another part is there which is assisting the motor now. That is a dynamic torque. Why it is assisting? Because you are not declarating. You are decreasing now. So when you are decreasing the speed, now this dynamic torque part is there. So it will assist the motor to meet the load torque. Whereas when you take the case of the acceleration, this d omega m by dt is positive. So in this case, the motor has to develop more torque, more than the load torque, to meet this dynamic part. Okay. So now the third case, just now we have seen. Third case is that it runs with constant speed. So when it runs with constant speed in the sense, after the deceleration or after the acceleration, anyhow the motor has to run with constant speed. So in that case, this part will become zero. When it is running with constant speed, this equation holds good. Which one? T is equal to TL. Motor torque is equal to the load torque. Just you see the fan. Sometimes you increase the speed of the fan. So when you try to increase the speed of the fan, what will what you will observe generally? The motor starts accelerating. After that, it will go to one speed, higher speed it will go. Then after it reaches the higher speed, you will find out that that speed remains constant. Okay, so that time the low torque is same as the motor torque. So these are the basic things. These are the basic things which you need to understand. Where you connect the motor, where is the load, what exactly happens when you connect the motor to the load, and what will happen when it is accelerating, what will happen when it is decelerating, and what happens when it runs with constant speed. So all these things you can understand from the simple example. Okay, so what you will observe now is that once you understand this one, then one important topic you require here is the four quadrant operation. What is the four quadrant operation that I will tell you now? So let me take there is a graph. So the graph is this is speed whereas this is torque. You take speed and y-axis, torque and x-axis. This is for the motor. This is for the motor. This is for the motor. So we are so what does mean by when there is an electric motor is there? When there is electric motor is there, so what will happen if it is the case? Okay. See, four possibilities are there. Four quadrants means four possibilities are there. You can see yourself. There are four quadrants are there. Two quadrant, second quadrant, third quadrant, and fourth quadrant. What do you find out in the first quadrant? What do you find out in the first quadrant is that see the speed torque are positive. You see in the first quadrant both speed and torque are positive. So when speed and torque both are positive, then what is power? Power is also positive. Why power is positive? Because power is your power. You recall 2 pi nt by 60. This is power. So power is proportional to the product of speed and torque. So as both are positive, their product is also positive. So the power is positive in the first quadrant. So it means that the motor is taking power now. See, power is positive in the sense here I will write there motor takes power. Power is positive in the sense motor is taking power. So from where it is taking power? Generally from the electrical supply. From the electrical supply it is taking power. So that case is this first quadrant. Now coming to the case of second quadrant, what is second quadrant? It says that second quadrant says that speed is positive, but the torque is negative. You see now, because torque we have taken as this one. Speed torque. Okay, so torque is negative. So when speed is positive, torque is negative. What is power? Power is negative. Why power is negative? Because it's a proportional to the product of speed and torque. So speed is positive, torque is negative. So you multiply, you will get negative. So power is negative. So when power is negative, what does that mean? Now it is taking motor gives power. That's the meaning of that. Negative power in the sense it gives the power back. It gives the power back. That is called uh, a negative power. It gives the power back. So you call this first quadrant operation. You call it as forward motoring. You call the first quadrant operation as forward motoring. So now you see the second quadrant in which motor gives power back. We can call the second operation as forward brake. So forward brake in the sense what we must understand. So this we call forward braking. In this case, speed is positive. So the speed of the motor remains in the same direction, but it is giving the power back.
Sir, your mic is off.
Yeah, I know that these are okay. Just I'm just turning off because of some disturbance. Okay, first I will write and I will just turn it on and I will explain.
Okay.
Okay, now you see all these four opportunities. Okay, see quadrant speed are both are positive. You see just from this graph you can understand. Speed and y-axis x-axis both are positive, so the power is positive. So because its product of is proportional to the product of speed and torque. So whenever you think that power is positive, always remember the motor is taking power. Whenever you got the answer power is negative, it means motor give the power back. That that's the meaning of that. Coming to the second quadrant, what do you find out is that speed is positive because its y-axis is positive, x-axis is negative, that is torque is negative. So then you do the multiplication, then torque becomes negative. So when the power negative, motor is giving back power. Motor is giving back power. Now coming to the third quadrant, you see both x-axis, y-axis both are negative. When both are negative, then its product is positive. So when product is positive, in the sense motor is taking power. It is taking power. Coming to the fourth quadrant, the x-axis is positive, that is torque is positive, y-axis is negative. So torque speed is negative. So in that case, the power is negative. You multiply positive and negative, you will get power as negative. So in that case, motor is giving back power. So these are the four possible operations. Now it has given a name. What is the name? Is that first quadrant name? First quadrant, the operation is given name as forward motoring. Second one as forward braking. Third one as a reverse motoring. Fourth one as a reverse braking. So here two words you will find out. One word is either it is forward or reverse. This is one thing you will find out. Second thing is that either it is motoring or braking. I will tell you how to remember these differences. So when do you find out motoring? When do you find out is braking? Is that whenever you find out motoring, remember motor is taking the power. So that motor is now working in the motoring mode. So in that case, okay, you find out this word motoring. When the motor takes power, it is called motoring. When the motor is giving power back, you call that as braking. You call that as braking. So now I hope you might have remembered this word braking. So braking in the sense, just like you are riding a vehicle, you apply brakes. So when you apply brakes, what exactly happens when you apply brakes? You are decreasing the speed of the vehicle. So when you decrease the speed of the vehicle, you call that as braking. You call that as braking. So when you decrease the speed of the vehicle, you call that as braking. So in that case, what is the possibility? The possibility is that that vehicle will give the power back to the source. Why it will give the power back to the source? Because when you apply brakes, okay, so it starts declarating. Just now I have explained this thing. Just recall the previous topic. This topic. When it is declarating, what do you find out when the motor declarates? What do you find out is that um, this dynamic torque part is there. It is negative. So when it is negative, then that negative torque will be in support of your motor torque. So it means in that case motor need to develop less torque to meet the load torque. So it means this negative part is getting added to your motoring torque. Okay, so that's the reason that here also same thing, that when you find out power is negative, when you find out power is negative, it means what you find out is that that one you call it as braking. You see here you find out braking, here you in the second and fourth quadrant you find out braking. So if you observe carefully the second and fourth quadrant, motor gives power. Here also motor gives power because you got the power as negative. You got the power as negative. So whenever it gives power back, you call that as braking. Why we are calling it as braking? In a simple thing that it's a simple example you can compare with your vehicle riding. So when you ride the vehicle, when you apply the brakes, you will feel yourself. What you feel yourself is that. So it is giving the energy back to the source. Just see the previous example that when you apply brakes, it means declaration. When it is declaration, this dynamic part becomes negative. When it's negative, then it will be added up to the motoring part. So it is, that is the reason that we put the word here braking. Okay, so when we find out the word braking, it means motor gives the power back. When you find out the word motoring, it means it is taking the power back. So when you find out motor is giving power back, when you find out the P as negative, when you find out the motor takes power, when you find out P as positive. And another is that what is meant by forward, what is meant by reverse. Now you find out forward motoring is there, reverse motoring is there. Forward braking is there, reverse braking is there. What do you find out here? Whenever you find out the word forward, when do you find out the word forward? You find out the word in the second quadrant and the first quadrant. When do you find out the word reverse? You find out in the third and fourth. So what is common in 1, 2 and what is common in 3 and 4? What is common in 1, 2 is that speed is positive. In 1, 2, speed is positive. Whereas in 3 and 4, speed is negative. So I can say this thing that when when n is okay, I will write here, I will conclude here. When P is positive, it is motoring. Whereas when it is negative, it is braking. This is the thing. Whereas coming to the case of the speed, when speed is positive, it is forward. It is forward in the sense it is moving in the same direction. You generally consider speed as positive in one direction, opposite direction you consider the speed as negative. So that you call reverse. When speed is negative, you call that as reverse. So speed is negative in the sense what? The motor is running in the opposite direction. That's the reason we call it as reverse. So these are the four possible operations of any motor. Okay. So why we discuss these two topics? Of course, these two topics are related to mechanical topics. Okay, but without understanding these two topics, you cannot understand you cannot understand the working of chopper, or you cannot understand how it works actually. So these are the two things you must understand before we go further in chopper control. First thing is that, yeah, what will happen when the motor accelerates, what will happen when it decelerates, what will happen when it runs its function. This is one thing you must understand. And second thing, what are the four possible operations of any motor? These are the four possible operations of any motor. So in every operation, you have particular values of speed, torque, power. In every quadrant, you have a particular values of speed, torque, and power. So these are the things you must remember. And when do you call it is motoring? You call motoring when the power is positive. You call braking when the power is negative. When do you call it is forward? When speed is positive. When you call it as reverse, when speed is negative. Okay. So then once you understand this, so then what we are going to do is now is that first of all, okay. So as we discuss with as we discuss as we are discussing today's class as chopper control one, okay, chopper control. So what we are doing now? We are controlling the chopper to control the motor, okay. But as of now, before this, what are the other topics? What are the other methods you have to control a motor? See, controlling a motor is nothing but what? You control the speed and you control the torque. That's the meaning of controlling a motor. So, what is the controlling a motor? You control its speed or you control its torque. That you call it as a controlling a motor. So, we are controlling that with the help of a chopper. So, that topic we are studying. What is my uh, what is my question here is that before this chopper, what are the methods we are using to control the motor? What are the methods? Some methods are there. One is resistance control method. Resistance control method. So resistance control method in the sense, what is there is that I have how to control the speed of a DC motor. How do you control the speed of a DC motor? You change the voltage to the DC motor. which is going to the armature of the DC motor. Okay, the DC motor. Okay, so here you have the voltage is there. So I hope you know the relationship between the supply voltage and the speed of the motor. Okay, so when you change the supply voltage, then the speed of the motor obviously changes. So now how do you do that? Is that you do with the help of a resistor. Say for example, I have a resistor here. Now you change the value of this resistance. You change the value of this. When you change the value of this resistance, then the voltage which is going to the motor armature also changes. When it changes, speed of the motor also changes. So that you call it as a resistance control. So it means by taking the help of a resistor, okay. So by taking help of a resistor, the armature voltage will be changed, so the speed changes. So with that, you can call it as you are controlling the motor. But what is the problem you face here is that the efficiency is very less. Why it is very less? Because you have a resistor. Lot of power will be lost in the resistor. Okay, that is one disadvantage. That's the main disadvantage. Now, forget about the remaining advantages. When you have when you have this much bigger disadvantage, we will not worry much about the advantages. Okay, so we will not consider this problem. Of course, I'm saying that this is one way to control the speed of the motor. Maybe some people were using this earlier before they advance towards chopper. So this is one way. Anyone can control the speed using the resistor, but we will not prefer this because the efficiency is very poor. Second one is that motor generator set. This is one way. So in this way, what we have here? We have a motor, we have a generator. So say you take this example only. This is the motor, and you will control the speed of this motor. Okay. So now you give the supply to the motor, armature supply. So what you do is that you will have a generator here. Say for example, you will have a generator here. Okay. So now the output of the generator is a voltage or electrical supply. So now now you have another motor here. Both are coupled. Both are mechanically coupled. So now what you do is now, so by varying the speed of this motor, by varying the speed of this motor, you vary the speed of this motor by somehow. You have some exhalation here. You also have some exhalations. I hope we might have studied this kind of thing even in the first unit also. That you change the excitation here. So when you change the excitation or do something so that the output voltage of your generator, output voltage of the generator will change. Okay, so what is the issue is that so the actual motor is there to which you want to control the speed. So to that motor we will change the voltage. How do we change the voltage? We will have a generator here, and the output of the generator is a voltage. So by controlling the generator, by controlling the generator, we can control its output voltage. Now how you control the generator once again is that you change the excitation or you change the mechanical input to the generator. Okay, you do anything else so that the output voltage here will change. When the output voltage here changes, so the speed of this will change. This is one way to control. In this case, even though efficiency is not so poor like in case of the first case, but still the efficiency is not that much higher here. Of course, it is higher than the first case, but still it is a little bit less only. And one more problem here you face is that, see, you have a generator, you have another motor, so the system is very bulky. System becomes very bulky. So, okay, so to control the speed of the motor, you are once again taking the help of a generator and a motor. So this is so the system size will become very large. So when system size will become, there is one problem because we have to occupy, it occupies more space. This is one problem. Okay, so that's one of the problems of the second term. Now third one is that AC link control. AC link control in the sense, what is one AC link control is that see, once again I will take the same that I have a motor whose speed I have to control. Okay, its speed I have to control. So how I'm controlling is that the voltage which is going to the motor armature, I will change that. So how to change is that first method is resistance, second method is water generator, and third method is AC link control. So in the AC link control, what you do is that first thing is that what you do is that you have, for example, you are getting AC somewhere. Somewhere you are getting AC. Then what you do is now you will have rectifier. Then the output of the rectifier is DC. Now DC. Now this DC you connect here. This DC you connect here. For example, the rectifier is made up of. Now assume that it is controlled rectifier. Control rectifier. Rectifier in the sense you have the control switches, not the diodes. You have thyristors or MOSFETs or not MOSFET generally thyristors or IGBTs you will take or BJTs also you can take sometimes. So you have a control rectifier here. So by controlling its base terminal or by controlling its firing angle, the output of your rectifier can be changed. This you have that's called phase control converter. You recall the topic. Phase control converter. Phase controlled converters are there. So these converters will take AC and it will convert the AC into DC. Now, what is there inside this box of phase controlled converter is that you have set of thyristors. Multi thyristors are there, or mostly they are thyristors only. Okay, they are thyristors. Mostly they are thyristors only. So these thyristors will be there, and you have several types of thyristors are there. Single phase thyristors, okay, three phase thyristors are there. Sorry, single phase control converters, three phase control converters. Okay, once again you have semi-converter, full converter. So several converters are there. Those converters will take here. Then by controlling those converters, the output of the rectifier will change. So obviously the input voltage to the armature changes. So obviously the speed will change. So this is one method. This way you can method. Now it is little bit complex. I will say it is little bit complex. This method is little bit complex, and the efficiency is also it's a higher. Now in this case the efficiency is higher, but still you have the scope to increase the efficiency, and also you can make this system very some more simple. So that fourth method is the chopper control. See the third method has no no much disadvantages are there. Okay, third method does not have more disadvantages, but even though it does not have more disadvantage, you still have the scope to do something using the choppers. So what is a chopper? I hope you might have studied in the previous semester also what is a chopper. Okay, so using this chopper we will control that. Example of chopper we got here. So here is the switch, the diode, here is the inductor, then here is the load. This is a base chopper circuit. Here you are. You see now this circuit is very simple compared with the third case that is converting AC to DC. So what the problem will be converting AC to DC is that you may need a transformer here. Here you may need a transformer in case of your rectifier, that is in case of your phase control converter. Because you need to step down the voltage. The voltage which is coming here is 230 volts. The voltage you require here is say for example 20 volts DC. Then in that case 230 volts you have to step down first to some around 20, 25 to 30 volts. Then after that you use the rectifier. Then this way you generally do. Okay, so more components are required in case of that. Now coming to fourth one is chopper control. Let's know basic chopper circuit. Basic chopper circuit. This is L, this is the two-wheeling diode, this is the DC, VDC is there. You see how this is V now. So what happens is that what is switch here generally with thyristor. Why we go for thyristor is that generally the voltage here is higher voltage. Whenever you want to operate at higher voltage, we generally go for thyristor. So in the chopper, what you find out is that you close the switch here. So when you close the switch, what will happen now? When you close the switch, when you close the switch here, the voltage here will come out will find out VDC. The voltage will find out here VDC. For example, this is A. If I want to draw the voltage across A with respect to time, then there are two cases. Close the switch or open the switch. When I close the switch, VA becomes VDC. So VDC. So this is VDC. When I open the switch, what will happen now? The inductor which was flowing earlier when I close the switch, it still continues to flow through the freewheeling diode D. Through the diode D. So when the diode is conducting, then it becomes a short circuit. So the voltage here is zero. So zero. So till this point, the chopper is on. I will take the time as T on. Till this point, the chopper is on, or the not chopper, the switch is on. So when the switch is on, the voltage here is VA. Whereas when the switch is off, we find out the diode start conducting. So when the diode start conducting, we find out zero voltage. So then it repeats. So this is one complete cycle T1 complete cycle. So then what is here VA? See, this VA is there. So this VA have to uh, pass through your inductor. So when it is passing through the inductor, then what do you find out when it is passing through the inductor here? V naught. What is V naught? You will get here. V naught. So now as the inductor is there, so inductor only filters it. It only filters here. So it won't add anything here. As the waveform is like this. Now this is not a pure DC. So with the help of this inductor, now this DC it may become like this. The DC may become like this. It will become like this. Why it will become like this is that this pulse, okay, which I have shown here, it is passing through the inductor. So when it is passing through the inductor, it smoothens this. So when it smoothens this, then the load voltage V naught, it may become like this, or it will become like this, I will say. Okay. So when it becomes like this, okay, when it becomes like this, what you find out is that, okay. So what is the average voltage you will find out? What is the average voltage you will find out here? The average voltage here is that you see now VDC into T on by total time. This you will find out as V naught. This you will find out as V naught. Average value. I will say VA average or V naught. Both are same because the waveform which I have done for VA here, this is the pulse. Now for that pulse you find out the average value. What is average value? VDC into TM, because you simply use the geometry here. The height of the pulse is VDC, the width of the pulse is TM. So what is the average value? You find out the area of this. You multiply height and width, that is VDC into TM, whole divided by the total time period. It is T. So then you got the average value. So this is the average value of the output voltage, or the average value of the voltage at A. So this is the average voltage. Now what is V naught here is that V naught is nothing but the pulse which is there here like this. So this pulse will pass through the inductor and it will get smoothened, nothing else. Okay. So it won't stop the DC content because the inductor won't stop the DC content. Because for inductor, you must know this thing that omega L is the impedance, omega is the frequency. So for DC, okay, its value is zero, impedance value. So it only smoothen up. It won't decrease the output voltage. Okay. So so this is the average value you will get from the pulse. So now you see here. What is the logic of the chopper control now? Now you see yourself. What I'm saying is that now the output voltage of the chopper you can control by controlling T on. So by controlling T on, V naught can be V naught can be easily find out. For example, what is the load here? Load, for example, you take the motor armature. You take, say for example, if you take motor armature as the load, it means here the motor armature voltage V naught can be controlled or can be changed by changing T on. So when you can change V on by changing T on, then you can obviously change the or you can obviously control the speed of the motor. That's it. So this is the chopper control. Simple chopper control is simple here that the chopper circuit is there. This red color box is there. This is the chopper circuit. So this is the motor, whereas this is the supply. So you connect this basic chopper circuit. And then you change then you control the switch on time. So when you control the switch on time, you have got this formula VDC into T on by T. So then you can easily control the voltage going to the motor. So obviously the speed of the motor will change. That's it. So this is a simple logic. And what is advantage here is that you have a switch, you have a diode, and you have an inductor. Now ideally these three components, they don't dissipate power ideally. So the efficiency is very high. That's the advantage. And the components, number of components are also less. So these are the advantages of the chopper control. Okay. Then so what is the advantage here is that so okay, once you got this, once you got this, okay. So how do you control this Kia? That is one question is there always. Okay. Here I will write here. V naught is equal V naught is equal V naught is equal dc into T on by T. Now this T on by T is there, is generally called as duty cycle. Represent alpha or sometimes D. Several textbooks they represent several. So V naught is equal to alpha into VDC. This is one thing you learn. Alpha is the duty cycle. So the alpha is the duty cycle. Okay, so V naught is equal to alpha VDC. Then how do you change alpha? Because what is the logic here? How to change V naught? You can change V naught by changing alpha. That's the logic we find out. So now how to change alpha? Okay, so alpha is equal T on by T. Several methods are there. One way is that I will see here now. I will keep T constant, whereas I will change T on. Only T on I will change. Then in that case alpha will change. You see here. Alpha is equal to T on by total T. Numerator you have T on, denominator you have capital T. So capital T is nothing but the time period. So I will keep the time capital T constant, whereas T on I will change. You call that as pulse width control. Pulse width control. It means T on in the sense what is T on? T on is nothing but this. This is T on time of the thyristor. So on time of thyristor. So this pulse, this is a pulse. So the width is there. So you control T on in the sense you are controlling the width of the pulse. So that you call it as pulse width control by keeping time constant. By keeping total time constant, then alpha value will change. There is one more thing I will tell you that. See, I will not change T on, but rather I will change capital T. Changing capital T is nothing but what? I will change frequency. Because, so when I change frequency, then in that case, what do you find out? See, changing the frequency in the sense, this is one pulse. So this pulse T on and this pulse T on, okay. So they may differ, but at the same time, what you find out, the frequency here is different from the frequency is F1, F2. More pulses are there in less time. Less number of pulses are there in more time. So its frequency is higher. So changing the frequency in the sense you are changing the total time. You are changing the total time. So that is also one method to alpha, because changing alpha in the sense either you change numerator or denominator, or you change both, so that alpha value will change. So by knowing this logic, okay, first one you call it as pulse width control. The second one you can call as frequency control. By changing the frequency control also, we can change the value of alpha.